All right, so fraction. Let me start. Right, let me get my pen. All right, reading this says. Right, so it says state, and this is from. Let's see what we're starting here with. We're starting with 20. Oh, the here was not on this one. Let me see. Not seeing it on. It's not showing on this one. But I probably start, if it's going in order, it would be 2019. So we will see shortly which one it is. All right, so let me scroll back up. All right, so we're starting with state two natural sources of hydrocarbons. So we have petroleum, and slash crude oil. So that's one. And natural gas. All right, then it says fractional distillation of crude oil produces several fractions that contain a range of compounds with very number of carbon atoms. Three of these fractions are labeled 1, 2, and 3. State the name of one of the fractions. State the name of one of the fractions. So the first one here, that would be refinery gas. So fraction number one, that's uh, refinery gas. Right. I remember in the diagram I showed you, it's mainly for domestic use, so can you put for cooking? Right. So I remember when I asked you in previous classes, I would say the main uses of alkane is as fuel, right? So it would come back into here. So the refinery gas for domestic use, such as cooking. All right. Cooking. All right. So as I said, I will send you the diagram after class, and you just study what each of these fractions are and their use. All right. And I will send you this. Let me save it so if anything goes wrong, it is there. So you don't have to write as yet. I'm saving as I'm going along. So you will have this document. All right, so question two now. Uh, all right. And also, so we have to learn to interpret and analyze questions, right? So let's go now. It says compound W shown in figure 2 as the characteristic odor of pears and is used in fragrances and as a food additive. All right. This is a hint, but I will tell you why it is a hint because I did not tell you during class. All right. But outside of that, right, just looking at the structure, I don't want you to see anything else. Focus on the structure. Do you know what? So when I get an organic compound, it typically represents a whole homologous series, right? So let's just check. Would this compound be an alcohol? All right, so let's start with alkane. Would this be an alkane?
No, sir.
All right. Would it be an alkene? Don't be afraid to speak. It's just a few of you here. Right? It's practice. Your exam is in like 2.5 weeks or so, 3 weeks. Right. So it's not an alkane. Is it an alkene? There's oxygen. So once you say oxygen, it automatically excludes what? It,
Alkyl.
it auto, sorry, please repeat.
It automatically excludes alkyl and alkene.
Right. No, do you see an OH anywhere on the compound? Do you see OH on the compound anywhere?
Also,
So it's not an alcohol. Do you see COOH on the compound?
yes.
No, COOH, as in C double bond O OH.
No, sir.
No,
All right,
sir.
so it's not alkene, it's not alkene, it's not alcohol, it's not carboxylic acid. So which other homologous series did we look at? Like, it's not the typical homologous series. It starts with E.
Sir,
Anybody remember?
sir,
Esters?
Right. So when you get a compound, you have to learn to analyze it. So it's not alkane. So once it's the oxygen, it can't be alkane or alkene. If it was to be an alcohol, there would have to be an OH, right? And it could not be a carboxylic acid because the functional group is in the middle of the compound. And remember, with carboxylic acid, it is always at the end. So you would have C double bond O OH if it was carboxylic acid. So let's just move these out of the way. So the functional group is in the middle of the compound, and that occurs with ester. So let's just zoom back out. Right, so we know it's ester. How we know it's ester as well is right here. When it says is used in fragrances, hold on, let me start the typing. Fragrances. So esters, they are sweet smelling compounds. All right. So if you make an ester in the lab, you it should give off a sweet scent, all right, a nice scent. So once they mention fragrances, just know it is ester, all right. Yeah. So once they mentioned is used in fragrance, that's a giveaway that it's an ester that they're talking about. All right. So let's hold on, wrong thing. So let's see what they're asking us to do now. So it says circle the functional group, right? I did that just now here. So this is the functional group for the ester. And it says identify the homologous series to which all right, we know it's ester. Let me just zoom down. Scroll down, I mean. So it's ester. All right. And then it says list three characteristics of homologous series. So just remind me again of the characteristics of a homologous series. So
Sir, you have
members,
to change the name formula.
similar chemical properties.
all right, just a second. So you would start it by saying members of a homologous series, members of a homologous series have, all right, go ahead now, have,
The
well,
same formula.
all right, so, all right, just a second. So they have the same general formula. What else? They have the same functional group. What else? You need to build up confidence. So Just answer. Don't be afraid to answer. What's the third one? So they have the same general formula, the same functional group,
Similar
and what else?
properties.
All right. Similar chemical properties. All right. If they had asked for four successive member, each successive member differ by a CH2 group. All right. So with this one, if you come, you have to start with propane in order to see it. So let me just show you quickly. So CH3, CH2, CH3. So that one is propane. And then, well, if you look at eth here, then butane, no, CH3, CH2, CH2, CH3. If you did ethane, there would be no CH2 group. Then you have one CH2 group for propane, two CH2 group for butane, and then you would have three CH2 group for pentane. So each successive member, it differs by a CH2 group. So this have zero, this have one, this have two, pentane it would have three, hexane would have four, and so on. So that is what this is saying. Each successive member differ by a CH2 group. Mm. No, you can't show it. If they ask anything about homologous series and functional group and that sort of stuff, those are like giveaways. You can't afford to lose any marks on these. All right. Let me just erase this. All right, next question. Then it says no, draw the, and by the way, if you have any question at any point, do not be afraid to ask. All right. So draw the fully displayed structural formula of two molecules that are produced when compound W is hydrolyzed by dilute hydrochloric acid. All right, let me just go back to the ester. All right, let me just zoom in. If you remember quickly, how do we get an ester? Anybody remember? Like, how is it formed?
When you react from alcohol and carboxylic acid together,
Right, that is correct. So it's between alcohol and carboxylic acid, and we join them up by removing a molecule of what?
water,
Right. And the next thing, when you get the ester, right, you separate it at the two oxygens. So you separate it here. Good. Which part is the acid? Which part is the alcohol? Anybody remember?
So
Right.
the left
So
is the acid and the right is the alcohol.
that is correct. Now this one is much easier to figure out because you have the double bond already showing. And remember, it's the carboxylic acid that have double bond O. The alcohol just have single bond C single bond O. Good. Now, if you get the condensed formula, this is what you will see. So again, separate it at the oxygen, right? The left hand side is the acid, the right hand side is the alcohol. Good. All right. So when you have your ester, right? So remember, ester is condensation. So when you join up two molecules by removing a molecule of water, that is condensation. Now, the opposite of condensation is hydrolysis. I don't remember who answered a while ago, but they said that we would remove a molecule of water, right? So to get this ester, we would remove a molecule of water. So all you have to do, right, when you're going to hydrolyze the ester, just draw a line between the two oxygens, all right? And then you do this. So C, C, double bond O dash, all right? So remember, this portion is the acid. So all you need to do, what needs, what do we need to make this a carboxylic acid? What is missing?
OH.
Exactly
OH.
right. So all you need to do now is put on the OH. And then now for this part, you draw it back everything starting from the oxygen. So let me do it up here. All right, so oxygen, 3 carbons, put on the hydrogens. All right. So now what is missing in order to make this an alcohol?
OH.
Right. So when you hydrolyze an ester, it means that to get back the acid and the alcohol. And it's not difficult. So remember, just separate the two oxygens. Good. The double bond O, or the one on the left, that's your acid. So the only thing you need to put back is OH on the acid, and you put back H on the alcohol. Because remember, that is how we got the ester in the first place. Take off OH from the acid and H from the alcohol. All right, so that is our acid. That this is our acid, this is our alcohol. Now, in the question, it says hydrolyze using dilute hydrochloric acid. The next option would have been sodium hydroxide or potassium hydroxide. If that was the case, you will put on the acid, so on the carboxylic acid, right? If you were using an alkali, such as sodium hydroxide or potassium hydroxide, do not put on the H on it. All right? You only put back the H if you hydrolyze it with an acid. But because you hydrolyze it, if you hydrolyze it with an alkali, for example, sodium, you're going to put the metal instead of hydrogen. So let me repeat. When you hydrolyze an ester with an acid, you get back the alcohol and you would get back the carboxylic acid. However, if you use an alkali instead, such as sodium hydroxide, you are going to get back the alcohol, but you are not going to get the carboxylic acid. You are going to get a salt. All right. So when you use alkali, you get the alcohol and you get a salt. When you use acid, such as sulfuric acid, you are going to get not the salt, but you are going to get back the carboxylic acid. Is that clear?
Yes, sir.
All right. So I'm just going to clear here and put the answer in the correct section. Let me just move this. Right, so the two structures, I would draw the carboxylic acid. It had 2 carbons. Let me just double check. Yes, 2 carbons. So it will be C, C, double bond O, OH. And the alcohol, that one had 3 carbons. And then it says, take the names of the 2 molecules. All right, what is the name of molecule 1? Anybody? What is the name of this compound here?
Sir, is it ethanol or ethanoic acid?
Right, ethanoic acid. Good job. Ethanoic acid. And what is the name of this one over here?
Propanol.
Right. Let me just save this as I go along. State the name of compound B. Hold on there. I think that. No, I think this. Oh, this not in the right order. Let me see what would have. Let me see if it. 2025. State the name of. We're not seeing. I guess that page is missing. Right, can we just start with compound W? 3A. Let me see. C 1, 2, 3, 4, 5. And this is saying we're missing something from that part. So I will have to check for it. But let me see this one. Compound A displays structural isomerism, and one of its isomer 2-methyl 2-butene. All right, so let's start with part B. So define the term structural isomers. Anybody remember what are isomers?
Isomers are compounds with the same molecular formula but different structural formula.
That is correct. So structure. Right. In the meantime, I want you to attempt this one. So draw the structure of 2-methyl but 2-ene. All right. So define it. All right. So structural isomers. Structural isomers. All right. So for the 2-methyl but2-ene, how many carbons are in this compound? Let me call on somebody. Pishabar, how many carbons should be in this compound? If it's bute, how many carbons is that? Somebody. Once it says bute,
Four.
4 is correct. So that's 4 carbons. Now, based on the name, which homologous series is the compound belonging to?
Alkene.
Right. And how you know it's alkene? Which part of the name did you use
Sir, the
to be
butene. It shows where the double bond is.
right? Once you see ene, right, we know it's alkene. So I'm going to put some letters A, B, C, D. Where should I put the between which 2 carbons should I put the double bond?
Sir, between B and C.
Right. So remember now, this is carbon one, two, three, 4. And when we name in our alkenes, we give the double bond the lowest number possible. So it's between 2 and 3. So that is why it is 2-butene. If you put it here, it would have been, so if you put it here, it would have been between carbons 1 and 2, and so it would have been 1-butene. Also, right, so they could have said 2-methyl, 2-butene. So remember, with the alkenes, you can put the number before the before the name, and you can put it between the prefix, which would be but, and the ending "ene." So it can be 2-butene or but 2-ene. All right. So with that said, now what else is missing? So so we have the 4 carbons. Should I just put on hydrogens only? So but 2-ene, 2-methyl. What is the methyl group? Anybody remember what the methyl group is? All right, so the methyl group is CH3. All right, so that's your methyl group. Remember, not every CH3 group is a methyl group. So, yeah, this is the chain, right, with 4 carbons. So this CH3 group is not a methyl group. The methyl group is a CH3 group that is attached to the chain. So the chain is in green. So the CH3 group attached to the chain, that's your methyl group. So this is methyl and carbon number 2. So it's 2-methyl, 2-butene. All right.
Sir, if it was 2-methyl, it would be, it said 2,2-methyl.
So, yes, it would say 2,2-dimethyl.
Okay, sir.
Yeah. So the 2,2 would mean that both of the methyl groups are on carbon 2. So the di is what would mean the 2 carbons. So the di is what would tell you it is 2 methyl groups, but the number is telling you the position of the methyl group. All right. So the prefix di-tri-tetra tells you the amount of a particular substituent group, but the numbers now tell you where the groups are. So I hope that cleared it up.
Yes, sir.
All right. I can let this stay. All right, so let's go to the next question. Zoom out. Question not. No, some of you in here wouldn't have done polymers. 1 second. All right, so when it comes to polymers, so before this, we would have been looking at simple organic compounds. But when it comes to polymers, it is referring to very large compounds, what we call macromolecules. Give me a second. Uh, All right, so polymers are large. So when you think of polymers, just think of a chain or even a train. So hold on, where's the pen? So this box would represent our simple organic compounds. But the polymer now is when we join up a specific molecule over and over again to form a large compound. So if you do biology, right? Protein, when you digest um, starch, and do you remember what it breaks down into? So starch, which is a carbohydrate, it is broken down finally into glucose, right? So starch would be a polymer, right? Which is formed from glucose. So this here would be starch. So this would be starch. So this would be starch. And then now one of these boxes would be glucose. All right. So a polymer is a large molecule. Now you don't on the exam you don't have to put the large molecule. You can just put that it is a macro molecule. All right. So a polymer is a macro molecule. So once you say macro molecule, we know it's a large molecule. So it's a macro molecule. And, and then now you're going to tell how it is formed. So it's a large molecule formed. And if you look at this diagram, right, it is clearly formed by joining many small molecules together. So it is that simple. So it is formed by joining small molecules, and these molecules are called monomers together. So that's basically it. We are making a large molecule by joining smaller molecules together. So the small molecule is the monomer, and the macromolecule, that is your polymer. Mhm. And that's it. And it says name the functional group of compounds C and D. All right, so let me just zoom back out. So what is the name? So when it comes to alkane and alkene, their functional group don't have a name. So it would just say state the functional group. So if compound C was an alkane, it would just say state the functional group. and you would put carbon to carbon, single bond. Alkene, carbon to carbon, double bond. But with the carboxylic acid now and the alcohol, it can ask you for the name because it have a name. So it's not asking you to write OH and COOH. It is asking you for the name. So compound C, what is the name of the functional group? Anybody? It's carboxylic acid, obviously. So what is the name of the functional group?
Sir, carboxyl.
Right, carboxyl. As we had said earlier in the session. And compound D,
Hydroxyl.
right. All right, so it asks for the name. All right. I will give you a table, or if you have this together already, you can just look at the uses. There's a table in it, but I will send it in the group as well. All right, so it says state one use of nylon. So I think we're familiar with nylon. I'm not sure. Well, let me zoom in so I can write it a little better. By the way, anybody nylon for who did well, most of you here, not in the extra class, so I can't ask that. Oh no, this is shaking up a bit.
Sir, is nylon used for clothing?
Right, it's on the polyester. But the sorry, I'm getting just give me 1 second. Da, 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 da. Right, so hold on there. Where's the so with nylon and polyester, the go-to is for clothing. Right, so if you don't remember anything, it's yeah, goat clothing is a sure answer. But outside of clothing, so fibers make fibers for. Hold on there. I'm going to add clothing first. All right, and then put two more carpets. Which I can just put used in the clothing industry. Polypropylene now, that's plastic, right? So once it's alkene, so remember when we talk about the use of alkenes and we say it's mainly used for plastic, we're actually not talking about like ethene and propene. We're talking about the polymer. So polypropene, polyethene, polychloroethene. So when we say it is used for plastics, we're talking about the polymers. So polypropene, it is used to make ropes. Hold on, what is happening with the pen? Give me 1 second again. Hold on there. Sorry about this. Polypropene, all right. So used to make, hold on, let me. So for polypropene, used to make ropes, carpets. So again, all of these are in the table that I will send you. And the plastic food containers, plastic food containers. All right. There will be more questions on polymers that we will look at. All right. All right. So before I continue, right. So when it comes to polymers, right, just know that they are large compounds, but they are made from a specific smaller molecules. So just think about and think everybody in here do biology. So just think of glucose, right? In order to make carbohydrate, we have to join up a lot of glucose molecules. That is how carbohydrate becomes the polymer, right? So glucose, it would be the monomer. The carbohydrate is the polymer. When it comes to alkenes, so polypropene, that's the polymer. So each of these would be a propene molecule. So we join up a lot of propene molecules, and so we call the polymer polypropene. Polyethene, we join up a lot of ethene molecule. Alright. So it's just joining up small molecules until we have a large one. All right, so let me just clear this out the way. Click save. All right, next question. So define the term cracking. So figure 4 shows compound a hydrocarbon, which is often produced from the cracking of petroleum fractions obtained through distillation of crude oil. So it is asking us to define cracking and state one type of cracking. So anybody remember what we said happens in cracking?
So the breakdown of long chain alkanes into smaller alkanes and alkenes.
Right. So we're just breaking up alkanes into smaller alkanes and alkenes. So let me just zoom up. Hold on. All right. Sometimes we can just say hydro. If you don't want to say alkane, you can just say hydrocarbons. So we're breaking long chain hydrocarbons into smaller alkanes, alkane and alkene molecules. And that's it. All right, so state one type of cracking. All right, so I'm going to tell you the two types. So we have catalytic, because it uses a catalyst, and we have thermal. All right, so it uses heat. Let me write that a little bit now. So the two types of cracking are catalytic because it uses a catalyst, and thermal referring to heat. And then no. So we finish with this one. Hold on. Yeah. All right. So next page now. List 3 characteristics of homologous series. I won't write on this page, but just tell me them again. So what are 3 characteristics of a homologous series,
Same
Functional
general.
group,
right?
general formula, and
Same
similar
general
chemical
formula.
properties.
Right, nice. Let's look back at compound A. All right, so now it says name the homologous series to which compound A belongs. So which homologous series does compound A belong based on what we're seeing here?
For alkane,
Right. How did you know it? So let me just go back. How did you know it was alkane?
so because of the carbon to carbon single bonds.
Right. Good. All right. So name the homologous series. All right. So it's alkane. And what is the general formula for alkanes?
So CnH2n plus 2.
CnH2n plus 2. And then based on this, what would be the molecular formula?
C6H14.
Right. C6H14. All right. So it says no. In the space provided, draw the fully displayed structure of two structural isomers of compound A. All right. I'm going to do isomers for C5H12 quickly and then let you do it for C6H14. Whenever they ask you to draw an isomer, just draw. So the first one you draw, just draw everything in a straight line. Good. So for this one, it has 5 carbons. So I do 1, 2, 3, 4, 5. And then you put on the hydrogens, of course. All right. And then for the second isomer now, all you have to do is remove this carbon at the end. So if I take off this carbon, it means that we have 4 carbons remaining in the chain. So my new isomer, I'm going to draw 1, 2, 3, 4 carbons. All right. All right, let me do this quickly. Put an asterisk at the ends, right? Good. You see this carbon that you take off, do not put it on the carbons with the asterisk. All right. So I can put it on this one if I want to. And then ensure that every carbon has 4 lines around it. All right. So additionally, remember, whatever you draw, it must have the same molecular formula. So this must have C5H12. Good. So just going again. When you get the molecular formula, draw everything in a straight line, right? And then you take 1 from it, which is what I did here. If you wanted the next one, let me just, sorry, hold on. Let me just zoom out a bit. All you have to do is repeat the process. Just take off a next one again, right? So that would leave you with 1, 2, 3. And remember, you cannot put it on the carbons at the end. So you put 1 above and 1 below. And then you put on the hydrogens. And that's it. All right. So this is C5H12, but they are asking you for C6H14. Remember now, they already gave you the straight chain here. So just think of this as the first isomer. So draw 2 more. All right. So because they draw the straight chain already, you can't draw it again. If they had said C6H14, if they had given you the molecular formula, then you could draw this. But they already put this one on the board. So just think of this as the first one. And when they ask you for 2, just think of it as drawing a second and a third isomer. So just remember, take 1 from the end, put it in the middle, and then take a next one from the end, put it in the middle. So I will give you 2 minutes to take an attempt. So you're doing C6, H14. All right. So I'll give you 2 minutes and just take a quick attempt at it. Let me just zoom out so you can see what I did.
Sir, do we send it to you via WhatsApp?
You can send it if you want to, sure.
Okay.
All right, so let me do that now. All right, so let me do this. Mm, All right, bum, bum, bum. Right, so remember the six carbons were already in a straight line. One, two, three, four, five, six. So if I take one from this, right, my isomer, it would have five carbons. All right, and then I'm not going to put the one I take off at the end. So that's it. You could put it on anyone in the middle. All right. So after that, all I
Sir,
need,
I sent mine to you, okay?
I marked it. Yeah, all of them correct. Ashanti, right? Yeah.
Yes, sir. I just saw it.
All right. And when you're doing this, just take your time because if you leave off any hydrogen, it's wrong. All right. So just ensure every carbon gets the right amount of hydrogen. So do not, whenever you're drawing, do not do it in haste because if you leave off a hydrogen, it's not the right structure. All right. All right. So in the meantime, while I do this second isomer, somebody tell me the name of this one up here. Well, they asked us for the name, Tony, right? So you can look at it and name it in the meantime. All right. So what I would do next, I can do two things. Just because this chain is long, I can just move this methyl group to carbon three. All right. But I'm going to break the chain. So I can take off a next one, right? And so my new isomer, it would have four carbons, right? And I can put one here and one here. By the way, C6H14, I think it have 4 to 5 isomers. All right. I think it has 5 isomers. So all we need is 2. All right, in naming the compound, right, you need to highlight the chain first. So all the carbons in a straight line, just highlight it. All right. So we have 1, 2, 3, 4, 5 carbons. So that's pentane. All right. Now outside of the chain, check if you have anything other than hydrogen. And if you look, we clearly have a carbon outside of the chain. So we have a methyl group outside of the chain. So for isomer 1, it's 5 carbon. So that's pentane. And we have a methyl group. So it is methyl pentane. And the methyl group is on carbon 2.
Two.
So it is 2-methyl pentane. For this one, do the same thing. Outside of the chain, we have a methyl group here, and we have another methyl group here. I want to use. This is carbon 1, carbon 2, carbon 3, carbon 4. All right. So 4 is butane. So let me just get to naming it. All right. So this one would be butane. And then we have methyl group, right? So it's methyl butane. But now we have 2 methyl groups. So that's dimethyl. So we have 1 methyl group, 2 methyl group. All right. So that's dimethyl. One of them is on carbon 2, one of them is on carbon 3. So it is 2, 3 dimethyl. I could have chose to put both of them on carbon 2, in which case it would have been 2,2 dimethyl. So that's an isomer, 2,2 dimethyl. So let me just I'm going to put the name of the other isomers. 3-methyl pentane. And we could also have 2,2 dimethyl, 2,2 dimethyl. 2,2 dimethyl butane. Wait a second. All right, well, let me pull up the other question first, so you can look at it in the meantime. All right, so you can look at this one in the meantime. Hold on. Yeah. Mommy, mommy, look here. Take out the chips out of the freezer for me. It fries out of the freezer. Yeah. All right, I'm back. Right, so state the name of compound B and compound C. All right, what is the name of compound B?
Sir, alcohol,
The homologous series is alcohol, but what is the name?
ethanol,
Right. Ethanol. And compound C?
Sir, propanoic acid.
Right. Propanoic. Hmm. Propanoic acid. All right. State the functional group present in compound B. All right. So this is state. So I'm going to draw it and give both the name. So the hydroxyl group is present in yeah, the hydroxyl group. All right. Then it says which of the two compounds B or C is more soluble in water. So keeping it. Oh, it just say which. It don't answer any explanation. Cause yeah. So alcohols, as you know, acids are more. Well, technically you wouldn't really know, but acids are more soluble in in water than alcohol. So which of the two compounds is more soluble in water? Compound. Three carbons. This is a longer carbon chain. Two carbons versus three carbons. Right, when it comes to these compounds, you look at two things. All right, so both of them are polar, right? Anybody and then do you know what polar and non-polar mean?
No, sir.
All right, so when you mix oil, is oil a hydro? When you mix oil and water, what happens?
Okay, follow my second.
Sorry, please repeat.
Sir, I'm not sure.
No, oil and water, me say no. As in, if you pour oil in water,
It does mix.
Oil floats at the top.
right? It don't mix, right? But if you put syrup in water or alcohol in water, what happens?
The syrup dilute.
Or it dissolves in it, right?
Yes, sir.
Right. So when we say polar, it has we say water is polar, right? So polar means that it is charged. Without going into too much chemistry for this level, once anything with OH, are you not? Okay. Once it has OH, it's polar. Good. So both the ethanol and the carboxylic acid is polar. However, so what you have to look at, right, is now the CH groups. So the reason why oil and water don't mix, oil is basically hydrocarbon, right? CH groups. So it is non-polar. Good. So oil is non-polar, but remember we said that water is what? Water is polar. So oil is polar. Sorry, oil is non-polar. Water is polar. So alkanes and alkenes, they don't mix with water because they are hydrocarbons, and hydrocarbons are non-polar. So before I get back to the alcohol and the acid, if you compare alcohol to alkane or alkane and alkene is non-polar, so they will not be soluble in water any at all. So water is polar, alkanes and alkenes non-polar, so they don't mix with water. Good. So that's out of the way. Your alcohol and your carboxylic acid, both of them are polar. So what will affect which one is more soluble than the next one? You look at the amount of carbons and hydrogens present. Your ethanol has two carbons and this one has 3 carbons. So even though technically this should be a little more polar based on the 2 oxygen and the hydrogens, you have to look at the length of the carbon chain. All right. So in this case, compound C is less soluble than compound B because of the amount of carbons present. All right. If it was ethanol and ethanoic acid, it would have been a different story. So compound B is more soluble. They did not ask for an explanation, but if they did, compound B is more polar. We could just leave it as that because it's CSEC. All right. Or you can say it as fewer carbons. KP is when we go into more explanation. All right. So let me just repeat for you now, right? Alkanes and alkenes, they are non-polar. Water on the other hand is polar. So they don't mix. Polar and non-polar don't mix. I don't know if you ever hear the term in chemistry, like dissolves, like it means that polar substances dissolve in a polar solvent. That is why your salt, your sugar, alcohol, they dissolve in water because both of them are polar. But oil don't dissolve in water because oil is non-polar. All right? Yeah. So just remember, once you see the OH, it's polar.
Sir,
But when you
alkenes
compare
and
the two of them,
alkenes are non-polar.
sorry, please repeat. Oh,
Alkenes and alkanes are non-polar.
that is correct. So you see, once you see OH, once you see the OH, it's polar. All right? Yeah. Or even just the oxygen and the carbon, it will be polar. Once you see just carbon and hydrogen, I'm just going to put NP for non-polar. If it's carbon and hydrogen only, non-polar. When you see the oxygen and the hydrogen, it's polar. All right, so both of these are polar. But this one is a larger molecule. All right. Oh, let me get the pen. Compound B. All right, so that one was completed. All right, 5AB. All right, then it says compound B is made during wine production using yeast. Name the process you name the process used to make B. Anybody know the name of this process? It starts with F.
Their fermentation.
Right. Fermentation. Describe the purpose of yeast in the production of wine. Does anybody know the purpose of the yeast?
Third, yeast makes the fruits into alcohol.
Right. So it converts the carbohydrate in the fruits or the glucose in the fruits into alcohol. So you're correct. Let me get this. Use this. It converts. It converts the sugar. just going to put glucose. So it converts the sugar in the food into wine. Sorry, this is converts the sugar in the food. Give me a second. This is moving a bit. It don't have to be fruit. Into ethanol. So when we're making wine, basically the key product is ethanol, which is the alcohol. So whatever sugar is present, so the foods that you use, it must contain carbohydrate, right? So we're converting the sugars in the food into ethanol. Well, not we, the yeast, right? So as you know, the yeast is a microorganism. And then it asks for the equation. So remember, we're converting glucose into ethanol. This, by the way, if you do bio, you should know this, right? Bio people, you do this in biology, right?
Yes,
When
sir.
you look at, when you look at aerobic, anaerobic respiration, so remember, like for anaerobic respiration in humans, the product is what? Lactic acid, right? But in bacteria, it's alcohol because it's fermentation.
Yes,
Yeah,
sir.
right. All right, so the equation now, what would we start with for our equation? We start with which compound? Glucose, right? So remember, we are converting glucose. So C6H12O6, and we're going to convert it to ethanol. C2H5OH. But we're also going to get carbon dioxide. The CO2. And over the arrow, the enzyme in the yeast, so is zymase. So if they ask you for the name of the enzyme, it's zymase. So the zymase is the enzyme in the yeast. Alright. So you're converting glucose into ethanol. So this is anaerobic fermentation. So there's no oxygen involved in this process. So so we use yeast. The name of the enzyme is zymase. So let me just put it here. So the enzyme is zymase. I'm plugging this laptop. I will send you another page with the basics of the fermentation. But the most important part is you have to remember the enzyme, the equation, and the fact that we use yeast. Mm, right. So that's that part. Go down here. It says compound D. So let's look back at compound D. What was compound D again? Oh, yeah. Right. So compound D and water are formed from the reaction between compound B and C. Oh, yeah. So compound D and water are formed from the reaction between compound B and C. All right, quickly. Compound B and C. What is it saying? Can anybody tell me what is being formed? So it says when compound B and C react, we get water and compound D. So which reaction do you know take place between alcohol and carboxylic acid?
Sir, esterification.
That is correct. Esterification. Excellent. Which means that compound D is going to be an a what?
and ester.
That is correct. All right. So all we need to do to get the ester, which of the compounds should we take the OH from?
Sir, the carboxylate.
Right. So the OH will come from this and the H will come from this. But remember, we always put the carboxylic acid first. All right. So you will take the and then the OH of the alcohol. So let me just do it, show you. So all they ask for here is to draw the fully displaced structure of compound D. So they did not ask you to show how it is formed. So all you need to do is draw the ester. But I'm going to show you how I get the ester. All right. So you would have drawn the acid, it will be on this side. Hold on, the little 3 carbons. All right. So the acid will be on this side, and then you flip around the alcohol as well, because you have to make they face each other. And then now you take the OH from the acid and the H from the alcohol. Right? That is how you get H2O. So you take the OH from the acid and the H from the alcohol, and then you join them up. All right. So that is what I will do up here. So the 3 carbons, that's for the acid. Keep the double bond O. Remember, all we took from the acid was the OH. So we took OH from the acid and H from the alcohol. So you're going to draw a line, right? And then you draw the oxygen that remains from the alcohol. And then everything else stays as is. Pay careful attention not to put any hydrogen on this carbon. All right. Remember, carbon only forms 4 bonds. All right. So these 2 lines, those are 2 bonds. So 2, 3, 4. So this is compound D. Let me just straighten this. Straighten that line. All right, so that is the ester. They did not ask for the name, but let me just remind you how to name the ester. So we know that this alcohol is ethanol, right?
Yes,
So
sir.
this is ethanol. So what you are going to do is remove the anal. right? And replace it with YL. So for the alcohol, you take off the anal and replace it with YL. And for the acid now, this would have been propanoic acid. Propanoic, right? You take off the IC and replace it with ATE. Good. Now in the name, so in this structure, the acid is always first, right? Which is on the left. But in the name, it's the alcohol that you put first. So the name of this ester is ethyl ethanoate. Ethanoate. Hold on. Noate. Let me just check that this is recording.
So
Yes.
isn't that supposed to be propanoids?
Yes, propanoate. Thank you. PROP. Oh, let me just put back the IC and highlight that is what we change. Hold on. So let me put back the IC and highlight it. All right. So we change the IC and let me put back the ethanol and highlight it. So and let me highlight the ATE down here. So you replace IC with ATE and you replace anal with YL. All right, so that's how we get ethyl propanoate. All right. Compound D can be used in the production of polymers. Define the term polymer. We did that already. All right, let me scroll down. State the type of polymerization that compound D undergoes. Compound D is, it was the compound D ester. Oh, it would be condensation. By the way, so there are two types of polymerization: addition and condensation. Alkenes does addition polymerization. So you see, once it's not an alkene, condensation is the answer. All right. So once it's not an alkene, condensation. Mhm.
Sir alkene does addition.
Right. Alkenes, addition. Anything outside of alkene, condensation. Anybody have any paper one on them or in their email can send me? I don't have any on this phone with me. Anybody have paper
Yes.
one? Can you WhatsApp me now? I want to do a little paper one to end this session. All right, send it in the meantime. Answer this one. All right, got it. Thanks. All right, so for this one, so what are the two sources of hydrocarbons that we looked at?
Petroleum
Mm-hmm.
and crude oil.
Right. Petroleum is the same as crude oil. The M word. No, not M. N.
Natural
Natural
gas.
gas.
Right. All right. Compound B. Is it alkane, alkene? What is it? Hold on. Let me zoom in a bit. All right. So compound B is C6H14. So is it an alkane or alkene?
Alkane.
Right. So if it's an alkane, what are two uses of alkanes?
There
Remember the.
solvents
Mm-hmm.
and lubricants.
Yeah. But you left out the easiest one. The easiest one. What you cook with?
Of fuels like
Yeah.
gas.
Right.
Oh,
Yeah. Mm. So fuels, solvents, lubricants. Yeah. Remember that fractionating column, but the main right. So fuel. Hold on. Edit. Hold on. Fuels. Hold on. Fuels, solvents, lubricants. And draw the fully displayed structure. Well, we know how to do that. All right, so let me pull up the paper one. Where is it? Refresh. Let's save. Oh, let me go save. Wait. Give me a second. Let me save the page I was just working on. All right, save. All right, good. Go up now. All right, so this is 2023. Let me scroll down to the organic chemistry section. All right, this. Right, so 45. So it says, which of the following hydrocarbons is the major constituent of natural gas? Which one is it?
Methane.
Right, methane is correct. I'll just put a slash. All right, 46. Let me scroll down. Which of the following structures represents a molecule of butene? All right, everybody take a minute, like 30 seconds, and then you can share your answer. All right, so I'm going to time it and tell you when you can share your answer. Let me find the timer. Stopwatch. All right, so just look at it, and then I will tell you when you can share. All right, anybody want to share their answer? Nobody? Anybody? Which one is 2-butene? All right, so
The A.
automatically C and D w- would be out
There
of
would
it.
it be A?
Yes, it would be A. So C and D is out because it's built. Father, give me a second. Puppy! Dad! Dad! Puppy nice. Come down. Dad, hey, come down. Move from the phone. Yes? Come on, come down. Come down. Yeah, sorry about that. Ready again. Right, so it couldn't be CRD because it's three carbons and it says bute, which is four carbons. So it's between A and B. Now remember, this is carbons one, two, and three. So it's between carbons two and three. So it is 2 butene. This would be between one and two, which would make it 1 butene. All right, so the answer is A. All right, 47 now says which of the following substances is used as a monomer in addition? So remember, once it's addition, which homologous series does
Alkene.
addition? Right. So all you need to do is look for the one that is alkene, which is
B.
right B, C3H6. By the way, alkanes are not used in any form of polymerization. All right. Which of the following reactions occur between propene and bromine? So
Addition.
right, because propene is an alkene, right? And we know that the characteristic reaction of alkenes is addition, right? Good job. Alkanes, substitution, alkenes, addition. All right. No, not. All right. So items 49 refers to the following chart showing the conversion of ethene to different products. All right. So the product polyethene is a anybody can tell me?
So is it a solid?
Right. Because polyethylene is a polymer. And remember, the polymers are plastic materials. So whether it's plastic pipe, the plastic container, plastic bags, right? So it is solid. All right. Let me just ask a next question, even though it's not here. What would be the product for I? So here, what would be the product? So the reaction taking place there. I could ask you for the name of the reaction. So the name of the reaction is hydration because you're adding water. All right. The acid is the catalyst. So the acid, that's the catalyst. All right. Sulfuric acid. So remember, whenever you add water to an alkene, you are going to get an alcohol because what you're doing, you're going to break the double bond and you add hydrogen to one of the carbons and OH to the next one. So you're converting alkene to alcohol. Bromine, you would break the double bond and you would get, so you would put two bromine atoms on it. So on the next paper, they could have asked you something. So they could repeat this question but change it up. So they could have asked you about part I, R, I on a different paper. Good. or even ask you for the name of the polymer that would have been formed instead of putting it here. Give me a second. Shall I mean a class? Mean a class? Mean a class? Mean organic chemistry past paper. Yeah, up to 12:30 and then we break. Yeah. Yeah. Alright, yeah man. Yeah. Alright, ready again. Bum bum bum. Right. So let's go to 50. It says an organic substance reacts with bromine. An organic substance reacts with bromine, water, and decolonizes it. All right. If you remember your organic chemistry reactions, right? You should know that we did not do any reactions of alcohol with bromine. We did not do any reactions of ester with bromine. So you see, when you study the reactions, it makes it easier for you. So once I see bromine, water, I know that it can't be alcohol, it can't be an ester. So it's between alkane and alkene. How will you decide? Is it alkane or alkene? If you remember.
Sir alkene.
How can you differentiate an alkane and alkene? Anybody remember? What would you use if you want to differentiate between alkane and alkene?
Sir, the bromine water becomes colorless when it reacts with the alkene.
Right. But nothing will happen with the
Alkane.
alkane unless what? Unless you do it in the presence of what? So alkanes react with bromine in the presence of sunlight, or you can say UV
Sir
light.
UV light.
Why
Light.
this not right? Right. So the answer is C, alkene. Alkanes will only react with bromine in the presence of UV light. All right. Or you can put sunlight, as that is a source of UV light. All right. Let me scroll down. 51. Which of the following compounds will react with ethanoic acid to form an ester? This should be easy. Which one is it?
So is it C?
Right. Alcohol. That is correct. So remember, ester is between carboxylic acid and alcohol. All right. 52. The compound which has the formula dash is, it should be easy as well, is what? 52. Is it alkene, polymer, carboxylic acid, and unsaturated acid? What is it?
Sir, an alkene.
Definitely. All right, because we see the carbon to carbon double bond. Don't mind the H, because if you draw the structure, it is CH3, CH at the top, C double bond, CH. All right, this is just the condensed formula. All right, CH, CH. And they put the double bond. They didn't have to put the double bond either. It could have just been CH, CH, and you would know that a double bond is there. All right. Which of the following statement is slash R? So it could be one or more than one that is true of alkenes. So can alkenes react with potassium permanganate? Remember the PD I did with the butter or the type of oil? Remember that PD? That should help you to answer this. Can alkenes react with potassium permanganate?
So they can?
Yes, they can. Because remember, we can use potassium permanganate or bromine water to differentiate between alkanes and alkenes. So the potassium permanganate, it will decolorize in the alkene. So remember, if you react it with the alkene, the product where of the double bond, you should get two OH groups. So for example, if you react ethene with potassium permanganate, you should get this compound. All right, so two OH groups. So it's oxidation. So it's oxidation of alkenes. All right. So alcohols and alkenes are oxidized by potassium permanganate. All right. So one is correct. How about two? They undergo addition reactions. Is that correct?
Yes, sir.
All right. They undergo substitution reaction. Is that correct? Do alkenes undergo substitution?
No, sir.
Correct. So alkenes undergo addition, alkenes undergo substitution. Mm. So the answer is 1 and 2, which would be part B. Oh, hold on. B. All right, 54. Which of the following organic molecule has only two isomers? All right, so hold on. C2H6, they don't have any. The first isomer start at C4H8. All right, so it is actually butane. So butane has two. So C4H10, it has two. C5H12, it have three. And C6H14 have five. But they typically ask you about butane and pentane. So butane has two, pentane has three. All right, next 55. It says which this graph, if you see it come back, pay attention to it. Don't just hot the answer because there are two of them. All right. So it's not the same graph on every paper. There are two. It will look the same, but something was different about one of them. I don't remember. But don't just sort the answer. Alright, so it says which of the following molecular formula represents the alcohol with boiling point of 160. All right, so 160 it would have been. Let me just zoom up. So each line is 10, so 150 would have been this here. So you're fine. This would have been 160. This line. All right. So it would have six carbons. All right. So you're looking for the alcohol with six carbons. So which of them have six carbons? Just count up the carbons. Which one of them have six carbons?
Let's see.
So it's C. All right. So five. It is C. So if you look, this is saying that you have three CH2 groups. So that's three carbons plus one, that's four. Four times one carbon, that's four. Four and one is five. Five ones, five. Five and one, six. So this have six carbons. This have seven. This have five, and this have four. So the answer is C, as I said. Good job. All right, and then 56. Which of the following compounds can be dehydrated? Which compound can be dehydrated? Ethanol,
Is it D?
excellent. Ethanol, I said, right?
Yes, sir.
Right, excellent. It's correct. So you hydrate alkene and you get alcohol. You dehydrate alcohol and you get alkene. All right, so good job on that one. Let me highlight it. All right, and then 57 now. Hexane has the formula C6H14. Which of the following statement is true of hexane? It is a covalent compound, so organic compounds, as we know, they are covalent compounds, so that would be true. Is it unsaturated or saturated? All right, so once it have double bond, it is unsaturated. So alkanes only have single bonds, right? Which means that it is unsaturated. Alkenes are unsaturated. Alkanes are saturated because they only have carbon to carbon single bonds. And this one is correct. It belongs to alkanes. So it would be 1 and 3, which is B. All right, and then one more. Yeah, during that is ferment, that is qualitative analysis. We will do that part next time. All right, glucose is converted to starch or cellulose by, I think you should get this one. Yeah, glucose is converted to starch or cellulose by, I mentioned it.
What
Starch
was
is a
57
polymer.
again?
60. Glucose is converted to starch or cellulose by which process? It can't be dehydrogenation. It can't be oxidation and reduction. It's polymerization. So remember, I told you that starch is the polymer, glucose is the monomer. So would it be addition or condensation? Which one I know does addition? The only one that does addition is
Alkene.
right. So the answer has to be
C.
D. D. Remember, it says glucose, is converted to starch or cellulose. So it has to be condensation because addition is only for alkenes, and glucose and starch, those are not alkenes, right? So anything outside of once they don't mention an alkene, it is condensation, polymerization, right? So starch is a polymer formed from glucose, right? By condensation, polymerization, right? So I did the multiple choice because it gave you a broader range of questions on a particular year. All right, so it's a bit past lunchtime, so we're going to pause here and resume in an hour. All right, so let me just save this. Computer's moving a bit slow. All right, so I will see you back at what is now. I'm going to stop the meet because I'm going to shut down the laptop and let it cool off in the meantime. All right.